nitrogen or behavioural economics, but then, and that's sort of the paper that I'll talk about now. So the plan, the ideas that I'm going to cover are that there are opportunities to reduce, a range of opportunities to reduce water pollution from nitrogen fertiliser, different things that farmers could do to combat that. Then I'll present, which is sort of where we started in this work, some neglected or forgotten or never fully recognised production economics findings that relate to those methods. I'll talk about some evidence that there are significant discrepancies between empirical evidence about physical or economic aspects of these practices and farmers' perceptions about them. So that's when it started to be interesting from a behavioural economics point of view. There seem to be these wide discrepancies between what farmers think and what seems to be the reality. So that made us think, well, maybe there's some scope for behavioural economics to try and close that gap. And then, so then what are the opportunities for nudges to do that, closing off that gap, those gaps? So just to make the case that there's an issue worth worrying about here, United States, so this is very American focused, okay? The work was all done in the US. So there's a dramatic, through the course of the 20th century and into the 21st century, there's been a dramatic increase in the use of nitrogen fertilizers in agriculture. And at the same time as that, there's been a dramatic increase in crop yields generally, but this is a graph for corn yields. If you look at how low it was, it's quite astonishing how much it's increased. It's not solely due to increases in fertilizer, but fertilizer is certainly one of the contributing factors that's made a big difference to yields. So that's a positive story, but it comes with a negative story because not all of the nitrogen, not all of the nutrients that are applied in general are used by crops, and a proportion of them end up in water bodies. And there are some well-publicised major water quality problems in the US due to predominantly nitrogen, to a lesser extent phosphorus and sediment, but nitrogen is the biggest single issue. And it's not just in the US. So this is a very famous case of the Gulf of Mexico. The Mississippi River sort of empties into here. All the nutrients from most of the central part of the US empty into the Gulf of Mexico. And it causes this massive algal bloom, which is basically, they describe it as a dead zone. There's so much algae growing there that it's sort of used up all the oxygen. No other life forms can live there. It's basically dead. And this thing grows and shrinks over time, but it's pretty much always there and it's always big. The US isn't and that's not the only place in the US that has problems like this, but the US isn't the only place. Actually, in fact, China probably has a worse problem with water pollution from agricultural fertilizers. It puts on insane amounts of fertilizer per hectare because it's very heavily subsidized. And so they have a big problem as well, but I'll be talking about the US today. And of course, this problem has generated a lot of interest and a lot of concern and a lot of policy efforts and research, some of which are illustrated on the screen there. But you'd have to say that the level of success so far has been pretty modest. There's still a big problem. Right, so what I'm going to do now is just go through the first thing we did in this work was sort of review the options, what's available to farmers to try and reduce their impact on water bodies. And so I've got a series of these to talk about briefly, just to describe initially. So cover crops, this is where farmers plant another crop or a pasture species at the time when the crop's not growing to capture nutrients that are in the soil, stop them from leaching or running off and hold soil in place. Zero till, so this is sort of, in the establishment of the crop, you don't plough it, so there's less loss of nutrients in soil, in runoff and erosion. There are buffer strips, so this is where you plant or you maintain an area of vegetation that's not crop around water bodies so that when shallow surface water or groundwater comes in and moves towards the water body, it gets picked up by the plants and it doesn't actually, a smaller amount of it actually reaches the water. Nitrification inhibitors, this is a thing where you actually apply chemicals to the soil and it changes the biology of the soil, changes the sort of the biochemical processes within the soil, so that the nitrogen fertilizer that you apply that ends up as ammonium, less of it gets converted through to nitrate, which is the thing that causes most of the problem. It's the mobile form that ends up in groundwater or moving off in surface water. There's variable rate technology, which is about trying to make sure that you apply the right amount of fertilizer that's needed to specific parts of the field, so that you don't have areas of the field that have got excessive amounts of fertilizer, which ends up not being used by the plants and then can move off the field. And there's the obvious and simple option of just reducing fertilizer rates. Put less on as something that could be done as well. So then there's others as well, which I'll cover briefly in a minute. So then we went through these options and said, well, out of those options, there's evidence about some of these are more or less effective and some of them are more or less expensive. So could we sort of capture that in a simple table? So we did. And you can see there are options in all 4 of the quadrants. There are things that are costly and not very effective, so we're not particularly interested in those. There are things that are effective but costly, so hard to get in place. There are things that are cheap but don't really work very well, so again, not very interesting. There's one thing that seems to be both cheap and effective, which is reducing fertilizer rates. So we focused our attention on that, and pretty much all of my attention today will be on that management option, the option of actually putting less fertilizer on.
Sorry, what's rate splitting?
Rate splitting is where instead of putting all the fertilizer on at the start of the year, you wait and see what happens, and if it turns out to be a poor year, you don't put a second lot on. So it means that there's some probability of applying less fertilizer overall. Yeah. Okay. So that was already a good reason to look at reducing fertilizer rates, but here's another one, which is that, so you know that I work on the adoption of innovations, and there's quite a lot of research identifying the characteristics of practices that are relatively easy to adopt, and it turns out that rate splitting ticks just about every box. And here are the boxes. Rate reducing, not rate splitting. Rate reducing is, as I'll show in a minute, at least low cost, and in some cases zero cost, or even in some cases perhaps slightly negative cost. It's simple to trial. It's not hard to sort of have a go in the field to see what the results are. It's easy to do. It's easy to understand what you're doing and easy to sort of see what's happening as a result. There are no upfront costs involved. You don't have to buy new machinery or anything to do it. It's easily reversible. If you don't like the look of what it's doing, you can back out of that strategy, which is something that's not always the case. It's a very familiar set of technologies that it's related to, and the evidence is that it's highly effective in terms of its reduction in off-site effects. So there ought to be good prospects for adoption of this as a practice. And if you look at many of those other things that I mentioned, many of those other techniques, they don't tick many of these boxes, right? They'll tick some, but this is the only one where we could be so optimistic that yes, we should be able to, if we do it well, we should be able to achieve high levels of adoption, which is interesting because we haven't so far in the possibilities to do it. So in thinking about that, we were looking for reasons why we might not have achieved high levels of mitigation of water pollution in the US so far, and we identified several what we're describing as untapped opportunities. This first one is relatively well recognised, but the next two are not. So the first one is just simple over-application. It's pretty clear that a reasonably large number of American farmers apply more fertiliser than they need to, even from their own private economic perspective. Here's one report from Tara Wade, who was in the Department of Agriculture, USDA at the time, and the table shows for several different crops the percentage of crop area across the whole of the US that they've assessed as having more nitrogen fertiliser applied than would be well, then relative to a benchmark, talk about the benchmark in a minute, but so fairly high proportions, 20 to 40% of the area gets too much. And the average amount by which it gets too much is quite substantial as well, 25 to 40 pounds per acre. And beyond that, I'd observe that the benchmark rates that they're comparing these actual farm practices to are biologically determined. They're not economically determined. They're probably too high, right? From an economic perspective, the rates, the true target rates are probably even lower again. So these numbers probably understate the extent to which nitrogen's being over-applied. So looking at, I'm going to talk about several possible contributing factors behind this persistence of over-application. One of them is misperceptions about the shape of the profit function. There's not a lot of evidence about this, but there's a little bit. One paper is this Sri Ramaratnam et al., who looked at a very specific situation, grain sorghum producers in Texas. But it's the only paper I can find that they really dug in deeply into what farmers' perceptions are and tried to sort of really understand what was going on. And they found that these farmers, at least, systematically overestimate the impact of additional nitrogen relative to empirical evidence. So they're very optimistic about what more nitrogen will do to their crop yields. And surprisingly, and perhaps disturbingly, in that case at least, they found that farmers maintained their wrong beliefs even after seeing experimental results. So this is interesting, if nothing else, right? What's going on here? They've got a lot of experience applying in and observing the results. How is it that they're getting such apparently distorted perceptions? So this is it reminds me of the sort of biases that are talked about a lot in the experimental economics literature. So what's the message from this? Well, the message from that group of farmers, the ones, the 40% that are applying 40 pounds per acre too much, is that there's probably private benefits from cutting rates. And policy approaches that we might think about there would include extension. Well, you might think of it, but it's already been thought of. There's a lot of extension about nitrogen rates in the US, and it hasn't really solved the problem. So there's something not working there. But then maybe, as I'm sort of hinting, maybe there's the scope here for nudges, some sort of experimental approach leading to the design of new ways of communicating, new ways of framing this issue that might make a difference. We've got plenty of evidence that nudges can make a difference in other situations. They haven't been tried in this context, so perhaps there's an opportunity there. It would be what I'm describing as an information nudge rather than a norm nudge. So it's trying to correct people's misperceptions rather than to persuade them to be a good person. Right? I'll come to be a good person later on. There's something to say there as well. But in this particular case, this possible misperception about the shape of the curve would be an information nudge. The second untapped opportunity is one that's not well recognised, and that's about risk. And so there's plenty of evidence, actually, that many US farmers see nitrogen as what's called a risk-reducing input. In other words, the more of it you put on, the less risky your production or your profits are going to be. And the same author, again, has got very good evidence of that for that particular situation. But in this case, he's not the only one. There are other studies as well that have made this case and surveyed farmers and basically concluded a lot of farmers think that more nitrogen is better from a risk management point of view. They think that it reduces the variance of profit or they think that it reduces the probability of a low yield. Interestingly, Faye and Marit and Fiona and Ben and I are part of a national project at the moment, and one of the issues that's come up in that project in Australia is that many Australian farmers are the opposite. There seems to be a view amongst scientists in Australia that farmers are not putting on enough nitrogen and that they might be overstating the riskiness of nitrogen. So we'll see if that turns out to be true when we do some research, but we'll stick with the US people. So a question is, who's right? And the answer is neither.
because there's very strong empirical evidence that changing the nitrogen rate within realistic ranges, within the vicinity of the optimal rate, has very little impact on risk. I'll show you a graph in a minute. But there's lots of studies that have looked at this, and it's absolutely clear. Not a single study has found that applying more nitrogen will reduce your risk. They've all found that it'll either make almost no difference or would increase it a little bit. So if anything, it's a risk increasing strategy to boost your nitrogen rate. And so that's true in many different contexts, different types of crops, different countries, different ways of looking at it, experimental data, farm data, modelling data, they all show that result. Here's some new results that are part of our new paper in this. This is just to give you an idea of what this is saying, what it's about. So we've got on the graph different rates of nitrogen fertilizer on the bottom axis. The vertical axis is a measure of profit. It's actually just revenue minus the cost of nitrogen minus some other costs, rental costs, in fact, I think, land rental costs, but a bunch of other costs are not deducted. What you can see is, okay, so on the graph, there's lots of these spiky things. So there are a set of results, modelled results, estimated from field data for a particular nitrogen rate. And so in the middle of those vertical sort of spikes, there's a little rectangle, and in the middle of that rectangle, there's a little bar. That little bar is the mean. So that's a sort of a statistically estimated mean level of profit for a particular nitrogen rate. And you can see it does what you'd expect. It increases, and then it sort of levels off, and if you go far enough, it starts to fall. Either side of those little rectangles in the middle is a big spike, and you can see a sort of a bulge. The bulge represents the probability weight attached to that particular level of profit for that nitrogen rate. So you can get a sense of how variable profit is as you vary the rate. And the really striking thing is that as you vary the rate, it doesn't have much effect on the variance of profit. Very small. So within the realistic ranges, so for the left-hand graph, the realistic range might be somewhere between 120 and 180 pounds, this is kilograms per hectare. It has almost no effect on the riskiness. If it has any effect, it's a slight increase as you go to more nitrogen. So around the optimal rates, nitrogen has almost no effect on risk. But this is the right-hand graph is just for a different phase of the rotation, but the result is more or less the same. If anything, there's a slight increase. So it seems clear that there are misperceptions by some farmers about this relationship, the effect of nitrogen rates on risk. All right, so the message here is that risk is no reason to increase your nitrogen rate. And policy options here could be extension, and this has not really been extended. This whole message around the evidence about the riskiness of applying nitrogen, I've never seen any extension of material that goes anywhere near that. So I think there's an opportunity there. There could also be an insurance sort of story. So this is about risk. Offsetting risk could be an insurance thing. So within our team, we talked about the possibility of compensating farmers for losses that result from cutting rates and trying to design an insurance product that would support them for that. And there have actually been some small pilots along those lines, but they've never really been picked up and taken off. And then maybe not just extension, but sort of some research in the field of behavioural economics to try and design some nudges that go beyond the sort of things that you typically see in extension. And again, it would be an information nudge rather than a norm nudge. It would be trying to correct a misperception that farmers have, or some combination of those things. So that's untouched ground. There really hasn't, almost untouched, apart from that little tiny bit of work on these insurance type products. The third one is my favourite topic, flat tail functions. So you saw on the previous graphs that things got pretty flat once you got up onto the plateau. That was for the US. This is a graph for Australia. This is Western Australia on a particular soil type, the relationship between nitrogen fertiliser and revenue minus nitrogen cost, and it's very flat, right? There's a wide range of nitrogen rates that give almost the same level of profit. And this is the equivalent result for the American data that I showed you graphs of a minute ago. If anything, it looks even flatter. So there's a couple of aspects to this story. If a farm is already operating at about the optimal rate, they're at the green dot, then they can cut their nitrogen rates below that optimum at relatively low cost. So if they are public spirited and would like to, contribute to a reduction of pollution for the good of everybody else, they could choose to do that at low cost to themselves. If they are one of the sort of large minority who seem to be over applying fertiliser, so they're over to the right of the green blob, then the benefit to them from cutting their rates back to the green blob is not very much. Maybe this is part of the explanation why they haven't self-corrected, right? If they're over applying, it's not a big mistake from a personal financial point of view. And so there's no real it's not going to hit you in the face that you're getting it really wrong. So you could easily sit there for a while and not recognise the need to move, or that there are benefits to move to the left. I guess another way of looking at that is that, okay, but there's no expected cost from moving to the left either. So there's a sort of a positive side to that possibility of cutting your rates. So some policy options this time. Extension, just giving evidence about how flat these relationships can be, at least within some range they're flat. And that's really not been tried. There's been, to my knowledge, no extension that's already really emphasised that. Again, complementing the traditional extension approaches, maybe we could look at designing nudges either to just the information nudge to correct or to sort of help people be aware of this reality, but also for this one, maybe we could even try and foster public spiritedness. Some of the nudges on consumers have tried to sort of make them aware of what other people in their community are doing, like that your neighbours are using less water than you, to try and encourage people to sort of cut back. Maybe something like that could be applied here, and combined with this evidence about the flatness of the curve, maybe that could be effective. Payments. The fact that it is so flat means that the governments could afford to compensate farmers for cutting their rates, and it wouldn't cost very much. Now, the American government has paid a lot of money to farmers to try and reduce nitrogen, impacts of nitrogen, but most of it has been on those really expensive options. There's been very little focus on getting them just to cut their rates. So I think there's a sort of an opportunity there to focus energy more and resources more on that. And then I guess another obvious option could be regulation, which to my knowledge is not used in the US, but it is used in Queensland. There's a relatively recent regulation being introduced to try and get Queensland, particularly cane growers, to reduce their fertiliser, and their fertiliser is mainly nitrogen, so that's an option too. All right, so we've seen a bunch of reasons why a focus on reducing nitrogen rates could be a good option to reduce off-site impacts from agriculture. One is the very first one I talked about, which is that it seems to be cheap and effective. And then there's these three sort of possible misperceptions. There's people who are over-applying, maybe don't realise that there's a win-win option available to them. Seems to be misperceptions about the riskiness of applying nitrogen, and there seems to be I think there's generally a lack of perspective or knowledge of the flatness of the payoff function. And as I said earlier on, there's probably, if we can get the messaging right and make people understand the problem well, there seems to be higher potential for adoption of this than pretty much anything else that's on the table. Right, so adoption. So I'm going to go very quickly here. I'm not going to show you what I've done here. You can ask about it in the questions if you want to, but I used adopt. So having got to that point, I thought, okay, I'm saying that it could have high adoption. How high? And so I got into the adopt model, which is our tool for predicting adoption by farmers, and tried to devise adjustments to the responses for American corn farmers to see how high a level of adoption might be realistic if we could convince them that the response function is fairly flat, that it's not more risky to cut rates, and that there's potentially a win-win and potentially an even bigger win-win if the government's going to pay them. And so I'm jumping just to the results here, and the results are that the nitrogen rates option was much better than the other options, not very surprising because those adoption characteristics that I described earlier on in terms of the level of adoption that seemed plausible. But even for reducing nitrogen rates, even if I could get nudges in place to fix all three of those things that I identified, I was still only, was still only predicting about 50% adoption. So that's flags that this is a difficult space, right? Even with the best available option, 50% adoption is a bit disappointing. And even to get to 50% adoption, I needed a combination of policy mechanisms, including a range of nudges and payments to get me to 50%. That 50% is far higher than the rate that's currently being achieved, but it's still disappointing. It was disappointing to me. Yeah.
Is that 50% of people who should, or 50% of the population, some of whom should?
Yeah, no, it's a good question. I'm trying to think how I set it up. It's a while ago.
No problem.
It's probably 50% of the population,
right.
I think, because I'd be including in that people going to lower than the peak rate. So yeah, so there's not a should there. It's getting more into the public spiritedness sort of side. Okay, so just to finish off, I guess a few thoughts then about what might be some research opportunities here from a behavioural economist's sort of perspective. Me not being a behavioural economist, but trying to bring these sort of other perspectives in to identify good opportunities for research. Okay, so the first one is to understand and quantify deviations between perceptions and evidence. So I've put forward that there's a bunch of misperceptions and put forward some evidence, but not all of that evidence is very strong or very widespread. I'd love to know what farmers, what a broader range of farmers really think about the shape of that relationship between nitrogen rate and profit, and what they think about the relationship between nitrogen rate and risk. There's very limited evidence about what farmers think about that. Right? There's good evidence on the risk side about what happens in real fields, but there's not good evidence about what farmers think. We'd need to know that it was farmers having misperceptions about that to think that it was worthwhile proceeding with nudges, right? Otherwise you're wasting your time. And I think at the moment we don't know if that's really what farmers think. And that could be misperceptions potentially about the relation. Oh, I've said that, but rates and profit and rates and risk. The next one is, if it turns out that there are significant misperceptions and they're widespread, then we could develop and test nudges and look at the size and the duration of their effects. Do these work? How well do they work? How long do they work for? In which circumstances do they work? And it'd be interesting to see the majority of work on nudges has focused on consumer behaviour. It's a growing body of work in agriculture, but it's still pretty small. It'll be interesting to see whether the sorts of results that we get for farmers are similar to the results we get for consumers, particularly because I think if you think about the level of attention to decisions that consumers are likely to make or to provide, my hypothesis would be that it's less than what farmers would do. If farmers are making a business decision, there's probably, so that's more likely to be what Kahneman would call a system 2 decision, where you actually reflect and get evidence and think about it, compared to system 1, which is a more intuitive, sort of immediate decision. So maybe through this we can correct the biased perceptions and or foster some public spiritedness. The next one, which is not about behavioural economics, is sort of look more at the design and the test of an insurance mechanism. There's been, as I said, a little bit of work. I think there's scope to do more. How would we set the premiums for that? What information sources would we need to evaluate claims? How do we minimise transaction costs? one of the few studies that's looked at this has concluded that transaction costs were a big problem. So can we minimise them? And in America, and we'd have to worry about, will this, if we offer this as an insurance mechanism, in what ways might it interact with traditional widespread crop insurance? They've got all risk crop insurance already. That's another, so will there be a sort of a crossover in the effects of these two insurance products? Or maybe should we build this one into the other one? I don't know. And then the last one is about payments, which is a very widespread approach in American environmental programs. And a question there is, what reduction in willingness to accept a payment to adopt these practices might there be when the biases are corrected? Assuming there are biases, right? We do that step. We decide there are biases. We design the nudges. We get rid of the perceptions, those misperceptions. How much does that reduce the willingness to accept? Interesting question. I don't know. And then will that interact with the nudges and with the insurance option? So it's a bit of a sort of a way. I guess what we're doing is sort of laying out a program, sort of a smorgasbord of research options for people that might be interested in digging into this. All right, so to conclude, some messages. I think it's fairly clear that the best option to pursue for reducing nitrogen fertilizer pollution is simply to reduce nitrogen rates for all of the reasons that I've outlined. A second message, which I haven't emphasised in the talk, but I think hopefully it's come through, which is about the value of focusing on the actual understanding the practice and the technologies that farmers have available to them as a precursor to thinking about your behavioural economics research. All right, so I think there's a lot to gain by understanding in detail the biology, the farming practices, the physical relationships before you just make decisions about what you're going to research from a behavioural perspective. And then the other message is that as I finished with there may be untapped opportunities to nudge farmers to improve their behaviour here. That's it. Okay.
Thank you, Dave, for this presentation. This is time for question. If you have one, please.
Can you monitor the chat in case there's something?
Yeah,
it looks like someone's typing something in.
Do you prefer that question?
So on the insurance,
Yeah.
do I need anything different to just having crop insurance? Because that presumably just triggers when I get, well, no, what are they doing? Are they doing weather index insurance or yield insurance? Okay.
I don't know enough about how crop insurance works to answer that with confidence.
So
This is a very specific, so the pilots that have been done, there's been 3 pilots done in different states of America, and they've all been based on underwriting the results of reducing your nitrogen rate. Right? So it's a very specific behaviour.
How do I know whether the downside is going to be as if I reduce my nitrogen and I've just...
So you have a there's various ways that they did it. The 3 of them did it in different ways. One of them did it by having a strip within the field that was managed with traditional methods. So you've got a point of comparison. Another one did it with modelling, which I think is a bit more dodgy, but that's what they tried to do. And then another one did it with historical data. I'm not clear about quite how that worked. How would you use historical data in a particular paddock in a particular year? Had me a bit puzzled.
Strip in the middle has some moral hazard problems, doesn't it?
It has moral hazard and it has cost. Yeah.
Yeah.
So in a way, this, I'm just thinking, looks like the reverse of what you have in developing countries, where it takes a lot of convincing for farmers to start using the commercial fertilizer, because it's just something completely new.
Yeah.
In the studies that were done, so time and again they are showing that they don't need to use that much. Is there an element of the farmers being farmers who basically come from the era of lots of fertilizer, or was there something like an age element? Like if you went back in time, have American farmers always been generous with their application rates, or is it more something that that's a history, but the individuals.
Yeah. Okay.
The individuals.
Yeah, you can't tell about individuals from that graph.
Yeah.
No,
Maybe
yeah.
they are just unfamiliar with this regime of like reduced rates, because it's for them there is no consequence.
There's another sort of thing that gets talked about in the papers. People are speculating. If you actually don't measure the details of the perceptions, then you're left with speculations. One of the speculations which I've encountered in real life is farmers aiming to maximise their yield rather than to maximise their profit. And so you end up with people overshooting, and then over here somewhere, if maximum profits is 120 to 160, so again maximum yield might be whatever, hard to read, but maybe 220, 240, but the difference in profit is very small, and so there's no real cost in overshooting, or no, and it's hard to tell that you have, right? You only get an observation in that year. So as I was saying earlier, it doesn't jump out at you that you've made a big mistake.
No, there is very little consequence to the farmer. It's all the external.
That's right. There's basically no cost to the farmer, but when you do overshoot, the bad part is that almost a very large proportion of the excess nitrogen does run off or ends up in groundwater. So a disproportionate amount of the more you apply, the bigger proportion of it runs off. Right, you get sort of increasing amount of losses with increasing rates. So the external cost increases at an increasing rate.
There's no incentive for the farmer to stop that.
No.
Yeah, we have a question from online attendee. Ross, can you?
Ross, do you want to unmute and ask the question?
Okay.
Sure.
So my question, David, is what policies or mechanisms might need to be developed to counter or expose the self-interest of agronomic consultants who advise farmers about the so-called desired appropriate level of N?
Yeah, that's a good point. Even more so than consultants, sellers of fertilizer are a significant source of information and advice to farmers. Yeah, I mean, that's a really tough question, isn't it? How do you counter that if farmers have a long history and they have learnt to trust them? Yeah, I mean, I guess it's doing your best, it's the classic thing of trying to win trust and provide good information. It probably won't happen quickly. You're not going to be able to regulate it in ARE-UWA, are you? You're not going to be able to sort of ban people from listening to their resellers, to their fertilizer sellers. So it's that's a sort of a problem that sits there. I agree, Ross.
I mean, about the only thing you know with nitrogen is there's a problem in the river. So, I mean, the long challenge with non source pollution is to have a policy based on that. And there might be, is there a possibility that there's a nudge for farmers in a catchment to say emissions into your river are excessively high? This is causing a problem with your and then perhaps linking that to farmers' soil testing or something else. Says that your neighbour is applying less nitrogen.
So I can imagine that's just exactly the sort of nudges that we've seen in sort of water consumption or electricity consumption in consumers. Sort of naming and shaming, pointing out to people that they're behaving in a less socially responsible way than other people, and that it's causing these costs. I agree. I think I guess I've tried to make the case that it seems to be a good idea to explore those sorts of options and see if they'll work. And that supplemented by information about the misperceptions that I've highlighted.
So then the insurance payments could be based on what's in the river rather than, well, that's probably straight.
Yeah.
Which is the only information you have because you can't observe what people are putting on their fields unless.
I'm remembering dimly research that has looked at that sort of approach in the past of rewarding groups of farmers for regional outcomes, agglomeration bonuses and stuff like that. And I wouldn't say I'm well across that research, but I know that there has been some work of that type.
Yeah, there's some experimental Spragan, I think,
Okay.
sticks in my mind because it's an odd name.
Yeah.
He did some experiments with students. And all that, so.
Yeah, I think it's be good to do with farmers.
Yeah, that's right.
Dan.
Just thinking about that for a second, that's, I mean, the typical problem with that you think would be like free riding, you know, it's a collective outcome, but it's sort of bizarre here because the free riding isn't really a problem because you're saying if they reduce, actually, their profit isn't really affected. So there might be free riding, but it would be sort of ill-judged free riding sort of thing. Yeah. But what I was going to ask was about the difference between perception and reality, and about have people looked at the whole kind of doubling down and backfire kind of biases, that the more evidence you give to people about something, they can double down and strengthen their view about their misperception.
Yeah.
And whether or not people have got into de-biasing techniques.
That's a great question. So for people online, if you didn't hear that, Dan is suggesting that there's a risk of people doubling down on their misperceptions. If you try and persuade them that they're wrong, they might say, bugger you, I'm right. And you use the term de-biasing techniques. I'm not aware of de-biasing techniques. What's
things like, well, changing how you present information is one. So there's a study of asking people about their methods in America about the welfare budget, and then telling people people overestimated the welfare budget. And then when you tell them what it is, they still sort of are against it. They did a different study where they said, what do you think the proportion of the budget going to welfare is? So they say 12%. And they say, what do you think it should be? And they say, well, no more than 8. And then you show them that it's 6. Right? Doing it like that has a different effect in terms of their view about it, or also just explaining to people about the nature of the bias that exists. Can have a difference before you even get to that. Just people respond better to anecdote than evidence. There's a range of those sort of things.
So that's great. I mean, that's sort of the sorts of framing experiments that people do in behavioural economics to sort of try out different ways of selling a story, selling it, whether it's to correct a misperception or to try and foster public spiritedness. Absolutely. I guess that's what we're trying to flag here, is to say, here is a particular narrow sphere which seems to be ripe for that type of research to happen.
So one question is, people often double down because the change in perception challenges their worldview. And I'm trying to think what worldview is here that is challenged by, other than I've been wrong. We all know it's not easy. No matter how much we do. I'm just trying to think about what the worldview that's challenged, what's kind of cognitive dissonance that's challenged. I don't know.
It might just be the perception that we have generally that more is better. We just have this idea about something, and then diminishing returns is a difficult concept for a lot of people.
I could also speculate that there's a sort of in the spirit of doubling down, there could be a sort of a backlash against city folk pushing for environmental benefits and imposing the costs, even though we don't show there aren't many costs, on hard-working rural Republican voters.
You've been talking a lot about misperceptions. How do we know misperceptions? I mean, have there been surveys around the now that be actually interviews there to get actually their point of view And why is it that they are, continuing this? Has that work been done?
So, no, it hasn't. As I said, there's been very limited evidence about what farmers actually perceive. There's a lot of discussion and speculation about it. There's a little bit of evidence from that Sri Lankan named paper, which did it properly, right? Actually did personal interviews and large numbers of farmers, and found clear misperceptions, right? So what seemed to be quite strong misperceptions. But as I said, I have no idea how widespread that is, and I think the first step is actually to establish that, right? Before spending a lot of money on nudges, actually understand the degree to which certain things are misperceived, if they are, and which of those things are misperceived, and then target the ones that seem to be.
The other thing is misperception also has a meaning relative to whatever their real objective function is, right? When we say profit, I said
I think I'm not touching their objective function except in that public spiritedness space.
No, I'm not talking about
the first two.
Just
it's about physical reality, right? If you put on this much fertilizer, you will get this much crop yield, right? That's not telling them what their objective function should be. It's about understanding the relationship between an input and an output.
A lot of things, you talked about risk, you talked about, the long term, do they have, rotational benefits there as well? I don't know. Do the rotational effects are part of that? Of
course, these decisions are complicated and affected by multiple factors.
It depends what they have in their mind, that's what I'm saying.
But if they have in their mind that fertilizer is a risk-reducing input, and they care about risk, that's another thing, are they risk averse, then you'd prima facie think that there's a high risk that they would be using more fertilizer than they would be if that misperception was corrected, right? That's the argument. Even whatever else is part of their objective function or whatever else other considerations are going on at the same time. It's just,
what about the fact that, small quantities won't be a problem, for bigger quantities changing fertilizer input, it maybe it's part of a package. So that if they're going to change the amount of the nitrogen, that means they're going to have to change about other things as well. I don't know, depending on what the cropping system is.
No, it's very simple. This would be the simplest technology.
So it can be
absolutely. Most of those guys could cut their rates by 30% and not even notice in terms of yield and profit.
And they don't need to change anything
No,
else.
Wouldn't change a single other thing, other than they wouldn't have to buy so much nitrogen.
Oh, okay.
It's not really a systems change. If it was a legume, there is a legume in the system, right? There's soybean in most of the corn production system, but that wouldn't change. That's still there.
There is one question online. Julian, can you unmute yourself?
Thanks, David. That was fascinating. Can I be heard? Okay.
Yep.
This is just an observation rather than anything else. The FAO, I know, is dead keen on this at a global scale, and I suspect that the World Bank would be very interested in this research as well. I suspect that there may be some information lurking in both of those institutions, perhaps quite old information, not sure, that would tie into this work, and it would certainly be valuable to reach out to those organisations and find out what they had done and what they thought about it. The FAO in relation to climate smart agriculture, the World Bank in relation to their insurance programs, obviously, and whatever difficulties and problems they'd had in practice in trying to reduce fertiliser use.
Yeah, okay, thanks, Julian. I think it's fairly country specific. But like
I thought you'd say that. Yeah.
In Atacody's comment, he mentioned that there are developing countries where the problem is not enough nitrogen fertiliser being applied to meet food security needs, and a big opportunity to increase it and make farmers and consumers better off. But in other countries, there's clearly too much. Like China is the one I mentioned. It's incredible how much fertiliser they apply. And everybody would be better off if they would cut it. They could cut it by, I would say, by more than 50%. So thank you.
Wow.
Yeah, good comment.
I think to add to what Dan was saying, an idea came to the mind. I don't know if that's the case. It could be that these farmers are reacting to agronomic advice that they received 10, 15, 20 years ago when they were sort of young farmers. Where they,
and it's established.
And it's established
Yeah.
itself. And now if you come and say they have to do something different, they'll say, I mean, I don't know, they could say, oh, so these guys are wrong. What tells me that you're not wrong too?
Yeah.
Now, and you're going, 5 years later, you're going to tell me to do something different.
Sure.
I don't know whether that's another factor or not.
I mean, it's that no one said this would be easy, right? So the US government spending, I don't know how much, probably billions, trying to address this. And so I guess all these complicating factors and challenges are real, and they're probably contributing to the fact that they haven't succeeded so far, right? They've got nowhere, well, almost nowhere so far. I don't think that this is a panacea. All I'm saying is that there's fertile ground here that hasn't been explored, for which there's a prima facie case that it looks hopeful.
And that's an cost.
And that's about as positive as you can get, I think, for this. And totally agreeing that it will be challenging, and totally agreeing with Ross that there are other things in the system that will go against this. But nevertheless, we can throw up our hands and give up, or I think this is the best option to try.
So the conservation reserve program, which promotes stuff, they don't have anything significant on this, like
the one that the program that you could probably that's closer to this is EQIP.
Yeah.
I can't remember what it stands for, EQIP, and it provides payments for a range of strategies that will reduce off-site nitrogen pollution.
Yeah.
But as I said, most of what they pay for is in that expensive, unattractive column.
Why do they target that?
That's part of it. It's hard to fake. If you're putting in buffer strips around your river, it's completely obvious. There's no mistaking it. There's a buffer strip there.
Monitorable from space.
From satellites. Yeah.
Wondering if there's another direction of the nudge. In the sense there are potentially some benefits going along the flat bit, which is my yield does go up, and I have bragging rights in terms of in my community. So is there any evidence that is what's partly driving them along there? And if it is, are there nudges that you can sort of remove high yields as being criteria?
Good. Yeah. I mean, as I said earlier, I think that people are going for high yields rather than high profits is part of the story, and social considerations, peer respect, and so on is almost certainly part of it. One of the unfortunate things about nitrogen is it does have a very visual aspect to it, right? It makes your crop big, and it makes it a rich dark or rich green colour, which stands out, right? So it's very easy to make it look like you're a good farmer by applying more in.
There's a literature on the good farmer and about perception of links to organic adoption, about your farm that's messy and it's got weeds and all this sort of stuff, etc., and the power of the good farmer. So maybe get back to that social loyalty or worldview which is being challenged, which is about what a good farmer is.
Agreed.